Once again, a wonderful afternoon to all the ladies and gentlemen, and welcome back after a amazing lunch. I'm sure you enjoyed the lunch. Yes? All right, cool. So, ladies and gentlemen, we have the next session all set to start. And for this session, we have two speakers who are going to accompany each other. The topic is practical natural language understanding from data to intent. Yes, ladies and gentlemen, our first speaker for this particular session is Mr. Nishant Chandra, data science leader at AIG. Dr. Nishant Chandra is a R&D scientist in the Office of Chief Data Scientist at AIG and leads the group in India. His primary responsibility is to develop natural language, speech recognition, and machine learning models for the insurance industry. Prior to AIG, Dr. Chandra has worked in insurance, telecommunication, and technology companies in US and India. Our next speaker for this section is Mr. Kiran, data scientist at AIG. John is a computer science graduate from Wageningen University, Germany, has 10 years of experience in the field of analytics and machine learning. Furthermore, John has experience in marketing analytics and big data technologies and is currently working with AIG Science on a number of initiatives in the areas of big data, machine learning, data engineering, and implementation. So, ladies and gentlemen, we are going to get more and more information about practical natural language understanding from data to intent. I'm sure you're going to enjoy this session. So, let's give a huge round of applause and please welcome Mr. Nishant Chandra and Mr. Kiran.
This working? Hello, everybody. Thank you so much for being here after big lunch and bigger dessert. How many desserts? Good, good. I'm not sure if, just very quickly, I want to know how many people have had natural language background, how many of you were part of the session yesterday. It'll just give me some idea of, how we can have this, run this session. Since it's a workshop, the idea is to kind of take one problem and along with you solve it end to end. And so just by quick show of hands, people who have some understanding of what natural language is have worked on it. Cool, cool. So we have about 50%. People who attended session yesterday on natural language, very good, very good. So sounds good. So what we would do here today is, along with my colleague John, we take the natural language and kind of demystify it, look at the practical aspect of exactly what natural language is, and take you from how the data is extracted, some of the theoretical as well as, mostly practical, some of the practical challenges, how we have when we get the data in. And once the data is all set and ready and John will get me the data in a plate, then I can come in and I will start touching on the natural language aspect of things. Okay, so John, the floor is yours.
Thanks, Nishant. Is this working? Hello? Can you hear me? Okay. I don't think this is working. Hello? Should I use this?
Use ಮಾಡ್ಬೋದಾಗುತ್ತೆ.
Yeah, thanks, Nishant. The presentation is, we're divided into two different sections. So one is the data part and the other one is the practical approach to natural language. And speaking about the data and the platform, maybe I can speak the whole day, but however, in just 30 minutes. So I'll try and manage to talk as much as possible. So let's go through a journey from what started in the 1970s, right, from the relational databases, and let's go towards distributed computing, the storage, and then the machine learning platform. Can't hear me? Oh, sorry. So I have to be here then, yeah. It's difficult to stand one place, yeah. So start the journey from the relation databases from the 1970s and to the early 2000 when the distributed computing came in picture. We had the NoSQL databases, and then we had how machine learning and complicated algorithms were able to run on the big data platform, right? So a short introduction to relational databases, and one of the main and primary features of RDBMS, maybe most of you must have already known, is the ACID property, right, which is atomic, consistent, isolated, and durability. When I say atomic, that means when during the transaction any logical failure happens, then the entire transaction is rolled back, or it is completely successful, right? That's atomic. The consistency means whenever any data is written into a database, it has to follow a strict schema, right? And isolation is every transaction is independent of each other, and they will be only visible when it is fully committed. And durability means data still exists even after the database, or there is a power cut, or the database is down. So this is the primary property of any relational databases. However, as we, the advances in the web technologies, and when a lot of more mobile devices and sensors started talking to the internet, and there was a huge amount of data being collected, and these traditional databases were of no help. So companies were looking for an alternative in terms of three main perspectives, right? So one is the technical point of view. They wanted to store data which is irrespective of any format. That is, they wanted to store sparse data, be it structured, semi-structured, or unstructured. And the second one is the cost. They wanted to have some kind of a platform which has, free of proprietary softwares and hardwares, right? And the third one is, again, they wanted to go in terms of agile technology, because the kind of business we have is so competitive. They wanted to get to the market as fast as possible and adapt to new technologies which the traditional databases were not supporting. So that's when the NoSQL databases came into picture, right, which follows the base property, which is again the opposite to what the ACID property is, which I will talk later. However, these databases have flexible schema, which means they can store in any format, and they're cheaper because they support run on commodity hardware, and they're massively scalable. That means you can extend horizontally as and when you want, and they're also highly available at the cost of consistency. So whenever we talk about NoSQL databases, we normally say in terms of the popular CAP theorem, right? So the CAP theorem says there is a main restriction in terms of any distributed storage, right? You can always satisfy any two property and let away the third one. So you can either have the best of availability and consistency and give away the partition tolerant, or you can have the other two and give the third away. So what does these properties mean? So availability means they are highly available. At any time, let's start with consistency. So consistency is, at any given point in time, the data is always consistent. So what one user sees, it's always same as what the other user sees, right? And availability means they are highly available, which means at any point, whenever databases should be able to accept and process a request at any point in time. And partition tolerant means the databases should be tolerant to partitioning. That means they should still function even when the data is partitioned, right? So let me give you a simple example. For example, you have a data which is stored into two different active partition nodes, probably equally stored into 50-50%, right? And when both these nodes don't take any write access, then what does it mean? It means at any point in time, they both are consistent with each other. they have the same data available all the time, right? So what if one or both of them start, start working on the right axis? So automatically the data gets modified, and at that point in time, they won't be consistent, right? So when you partition the data, either you have availability or you have consistent, but you can't have both. Right? That's how we interpret the CAP theorem. Right? So you can just stop me if you have any questions. So we have a lot of databases in the current industry. In the recently last 5 to 10 years, we've seen many distributed storages or data stores coming. So normally the typical RDBMS, all the asset properties fall under the availability and consistency, which means they cannot work on partition. And when you see in those which have primarily on the availability side, we have the popular ones. Of course, I can't name all of them. I just picked a few popular ones like DynamoDB, Cassandra, Simple, Couchbase, and Rack. And then from the consistency perspective, we have MongoDB, the online application, the Neo4j. Neo4j is actually an asset property, one of the NoSQL databases that have the asset property, similar to the RDBMS. However, Neo4j doesn't work well with partitioning like the other NoSQL databases, right? So we have HBase, which well integrates with the Hadoop platform. So all of these actually fall under the 4 different categories of data store. So what are they? Starting from the very basic simple model, we have the key store data model. So where all our data